Hi guys, this is Mrs. Schoenberg, and I'm making a video. We're going to do a few problems from the MA065 study guide for module exam. I have this pulled up here on my screen, and the very first one, can't see the instructions here, but it basically says to simplify this right here, negative 6x to the negative third power. So we need to, first of all, take care of that negative exponent. To do that, we're going to move it from the top to the bottom. Now, negative 6 can stay on the top in the numerator because it has a positive exponent. Once we move x cubed down to the bottom, that exponent becomes positive, and that is the answer to the problem. The next one, it says simplify the expression using the properties of exponents, expand any numerical portion of your answer, and only include positive exponents. Okay, 3 x to the 0 is equal to 1, plus 5 y to the 0 is equal to 1. So 3 plus 5, and the answer there is 8. All right, number 3, simplify the expression using the properties of exponents, expand any numerical portion, and only include positive exponents. Okay, this is one where we need to apply this 3 to all numbers within the parentheses. If there's already an exponent there, we need to use the properties of exponents and multiply. So what I have here really is 2 to the third power, a to the 2 times 3 power, b to the negative 1 times 3 power, and b to the 2 times 3 power. Okay, next I'll have 2 to the third power is 8, a to the 6th power, that is going to be b to the negative 3 power. And on the bottom here, I have b to the 2 times 3 power, which is b to the 6th. For the last step, I'm going to move this negative third power, b to the negative third, down. So I have 8, a to the 6th, and I have b to the 6th, and then I'm also going to have a b to the third power. So for my final answer, I'm going to need to add the 6 and the 3 together. So over here, final answer is a, 8a to the 6th power over b to the 9th power. Okay. Number 4 here, it says consider the following expression. 5x to the 6th power minus 8x to the 4th power plus 8x. Step 1, the given expression is a polynomial. Determine if the polynomial is a monomial, binomial, or trinomial. So C, there's 3 terms, so that is a trinomial. Determine the degree and the leading coefficient of the polynomial. The degree of this polynomial is 6, and that comes from the highest exponent. The leading coefficient is going to be equal to the number that precedes the x to the 6th. So that's going to be 5. All right, next up is number 5. And we're going to perform the indicated operation. And we're going to apply this negative sign here. So remember, that's going to, it's like multiplying a negative 1 times everything inside the parentheses. So when I write this, I have x squared plus 8x, and then that'll be minus x squared, and then plus 4x. So if I have x squared minus x squared, that's going to be 0. And if I have 8x plus 4x, that is 12x. So the answer to this one is 12x. Okay. Number 6, it says perform the indicated operation by removing the parentheses, combining like terms. This one, there is nothing, since this is a plus, we are simply going to combine our like terms. Let's see, we have plus 6x squared plus 9x minus 2. So it looks like I have x squared plus 6x squared, so that's 7x squared, plus 9x, and then minus 6 minus 2. So minus 6 minus 2 more is minus 8, and that is the answer there. All right, now we're into where we learned about foiling. We're going to multiply the polynomials using the distributive property. Also, you can FOIL. So first off, I'm going to take x times 2x, and that's 2x squared. And then x times -1 is negative x. 8 times 2x is plus 16x. 8 times -1 is minus 8. So then you'll combine these like terms here in the middle, and you'll have your answer. Okay, this one, we're going to multiply the polynomials. Remember how we did this? We took x times every single term first. So x times x squared is x cubed. X times 10x is plus 10x squared. X times 100 is plus 100x. Then we're going to take -10 times all three. So we have minus 10x squared, negative minus 10, minus 100x, and it's going to be minus 1,000. Okay, combining like terms, I'm going to have x cubed. Then let's see, plus 10x squared minus 10x squared, okay, plus 100x minus 100x, okay, and then we just have minus 1,000, and that is the answer there. All right, moving on, we'll skip that one. That one's a FOIL. Don't forget on this one, before you FOIL, expand it first, because there will be a middle term, okay? Finding the greatest common factor. Remember when we looked at this, we would look at, like if you examine the 3, the 5, and the 7, there's no common factor between the 3, 5, and 7, other than 1, and we don't write that. We have x, x cubed, and x squared, so that each term has an x. So we take the smallest x, if you will, so x to the 1 power. And then a y, there's a y in the first term, a y in the second term, but not a y in the third term. So really, our greatest common factor here is x. Factor the given polynomial. Notice the negative sign here. Also, can we take a 3 out of every single term? Yes. Can we take an x out of every single term? Yes. And then we're going to rewrite the expression. Okay, so I'm simply going to take a -3x out of every single term. So what I'm left with is y squared. That's going to make that sign positive. 3 goes in there 7 times. Take away 1x there. And then that's going to make this last term positive. And 3 goes into 9 3 times, and the x's will cancel. Okay, so this is the answer. All right, I took a -3x out of every single term, and I came up with that. Now, when you read the instructions, it's really important when you're taking the module exam to read the instructions, because all it wanted us to do here was finding the greatest common monomial factor and then rewriting the expression. That's what your answer should look like. Okay, factoring by grouping. Okay, remember how we set up these parentheses? In this first set, we're going to take out a c, and we have an r plus w. In the second one, we're going to take out, looks like an x, and we are left with an r plus w. Notice that inside of the parentheses, it's the same. So when we write our final answer using grouping, we have c plus x and r plus w. So far, so good, right? All right, this is where the class took a little more challenging turn. We started factoring or reversing our foiling, right? So right here, right off the bat, notice that we can factor out a 2. After I factor out a 2, I have x squared minus 7x plus 6. X squared minus 7x plus 6. Okay, from there, let's see if we can factor any further. I have an x and an x. See, I have a plus sign here. This is plus 6, and a minus sign here, so I know it's going to be a minus minus. And I'm already thinking to myself 6 and 1, because -6 times -1 is 6. And can we get to this -7? We have minus 1x and minus 6x. Yes. So that is the answer there. All righty. We're going to skip 15. 16. Let's take a look at 16 here. On number 16, there's nothing we can factor out first. Okay, let's try the AC method on this. A, B, and C. So first we're going to take A times C. So we're going to take 5 times 2, which is 10. Okay. Then we're going to try to come up with factors of 10 that when multiplied are 10 and when added are 7. So that is really 5 times 2 is 10. and 5 plus 2 is 7. So we're going to use 5 and 2 to rewrite the middle term here, okay? So 5s squared, and then I'm going to choose the plus 5s plus 2s, and then plus 2. Notice that 5s plus 2s is still 7s, okay? Now let's factor by grouping. I'm going to take a 5s out of this first one, so I am left with s plus 1. And then on the second one, I'm going to take out a 2, so I'm left with s plus 1. Good. So I have s plus 1 and s plus 1 in the parentheses. So I have my final answer is 5s plus 2 and s plus 1. That would be the answer there. Okay. Some of these others, factoring the trinomial. This would be another one to use that AC method on. This one right here, let's look at this. This is a special factorization. Why? There are two terms. Is it the difference of two perfect squares? Why, yes, it is. Following the pattern, okay, one will be plus and one will be minus. The square root of 9x squared is 3x. The square root of 25y squared is 5y. And that is the answer. Because remember, on these, the middle terms cancel each other out. So we have 9x squared, negative 25y squared. This one, not factorable because it is the sum of two perfect squares. Okay, this one right here is the sum of perfect cubes. This is the one where x to the 6th and plus 27. Let's see. So my a cubed term is x to the 6th, and my b cubed term is 27. Okay, then I'm going to finish out my little chart here. So if x to the 6th power is 8 cubed, what is the cube root of that? A is going to be x to the 2 power. And a squared, squaring this, would be x to the 4th power. And then b, 27, the cubed root of 27 is going to be 3, because 3 times 3 times 3 is 27. And then squaring that for b squared is 9. And then we also need the a times b term. And in that case, this is going to be 3x squared. After I have that handy, remember, we can use the module exam formula sheet, and there's a pattern on there to follow. And since this is a sum of two perfect cubes, this is the pattern. It's parentheses a plus b, so parentheses x squared plus 3, and then parentheses a squared minus, let's see, so a squared is x to the 4th, minus a times b, which is 3x squared, and then plus b squared, which in this case is 9, and that is the answer, okay? All right, moving on here. Let's go ahead and solve this. And look what it says here. We're gonna consider the following quadratic equation. This is the one where we have to set it equal to 0. So we're gonna need to move this 28x over, and then we're gonna factor it. Okay, so step 1 says factor the left-hand side of the equation into two linear factors. So if you have negative 16x squared minus 28x, and that's going to be equal to 0, okay, because I moved the 28x over by subtraction. Now, what can I factor out of this? So it's going to be a negative, and is 4 the biggest thing? 4x, negative 4x, let's factor that out. So now we have 4x plus 7 is equal to 0. So the answer here is negative 4x and 4x plus 7. Then solve the quadratic equation, okay? So now we need to set negative 4x equal to 0 and 4x plus 7 equal to 0 and solve. Dividing by negative 4, x is equal to 0, and over here we have minus 7. 4x is equal to negative 7, dividing by 4. We have x is equal to negative 7/4. Okay, so we have x is equal to negative 7/4 and 0. Okay. This one, the next one, 24. You would also move this one over here. So we have x squared plus 5x plus 1 minus 7 is equal to 0. X squared plus 5x plus 1 minus 7 is minus 6 is equal to 0. Let's see what we have here. X and x. This is going to be a minus plus situation. So could we do, and it needs to be positive 5, so plus 6 minus 1. Okay. So the two factors are x plus 6 and x minus 1. And then solving this, we have x plus 6 is equal to 0, and x minus 1 is equal to 0, minus 6, minus 6. So we have x is equal to negative 6, plus 1, and x is equal to 1. So the solution set is negative 6 and 1. All right, and then this very last one, this is the difference of two perfect squares. Following the pattern, one is plus, one is minus. You take the square root of each, and there you have it. Okay, that is the whole study guide review. I hope that helps. I hope that raises your comfort level with this exam.